All right. First thing to know is the number a is a square root of b if a squared equals b. So when we're looking for a square root, we're looking for the number that you multiply itself by itself to get the number you're looking for. All right. The example they give is 4 squared equals 16 and negative 4 squared equals 16. So if I'm looking for the square root of 16 in general, when it deals with a variable, I'm going to say 4 and negative 4. All right. They give a little bit of terminology here. All right. The radical symbol. So that's a term that you need to know. The radical symbol is this square root sign that you're used to. So then when you look at the square root of 16, just given it by itself without a variable involved, then they are always looking for the positive root, which is called the principal square root. All right. So if there is no variable involved, if they don't say x equals the square root of 16, if they're just saying what is the square root of 16, you would say, well, that's just 4. If you are putting it into an equation and you have to square root both sides, then you have to indicate it could be 4 or negative 4. So if there's a variable involved, you want to include not just the principal root, but also the negative square root, which is what they indicate right here. Negative in front of the square root of 16 means that they're looking for not the principal, which is the positive root, but the negative square root. And so the negative square root would be negative 4. They also use this symbol right here, this plus or minus on top of each other to indicate both roots. So for example, if I had something like x squared equals 16, to find that, I would take the square root of both sides. So I would say, well, x is going to equal the positive and negative root of 16, or x equals positive or negative 4. So that little symbol is indicating the positive and the negative of the number behind it. All right. Simplify the expression. So these are just looking for principal roots here, or negative roots if the negative is in front of it. All right. So the first one, square root of 64. Square root of positive 64, hopefully you know that one, is just positive 8. For B, they are looking for the negative root of 100. Well, the root of 100 is 10, so the negative root is going to be negative 10. For C, this is a fraction. When I'm taking the square root of a fraction, just do the root of the top and the root of the bottom. In this case, they want the positive and negative root here. So we're going to say the square root of 9 is 3. The square root of 16 is 4. So this would be positive or negative 3/4. All right. D is a special case for 0 because 0 is neither positive or negative. And so you don't have to worry about the positive or negative root. Any root of 0 is just going to be 0 itself. Let's look at this last one. The square root of negative 16. Here's the deal. When the negative is inside the root, you cannot do it as long as you are talking about square root, because there is no number that you can multiply by itself to get negative 16. All right, because one has to be positive and one has to be negative to get a negative number by multiplication. And so just by sheer definition of multiplication and how we do it with positive negative numbers, if you have a negative inside a square root, that is not possible. And your answer is going to be that is undefined, that you do not have an answer for that one. So go ahead and try check understanding 1, all 4 of those. This one is looking for the principal root of 49. You should have gotten positive 7. B is looking for the principal and the negative root of 36, positive and negative 6. C is looking for the negative root of 121, which gives you negative 11. And D is looking for the principal root of 1/25, which is 1/5. All right, the next example is just defining rational and irrational roots, all right? And so for this class, if it is an irrational root, meaning it does not have a perfect root, then you will leave it in the square root sign as your answer. So examples of rational roots here, square root of 100, well, that has a perfect root, it is 10. Square root is positive and negative root of 0.36, yes, 0.6, positive and negative is that root. Square root of a fraction, as long as they both have perfect roots, that is a rational. But irrational numbers, remember irrational numbers from way back at the beginning of this book are numbers that as a decimal do not terminate or repeat. All right, so the example that we always use is pi. And then some of the examples we used were roots that did not have a perfect root. Square root of 10, while they have rounded this, square root of 10 is irrational, meaning that decimal goes on continuously. And so anytime you have a number that doesn't have a perfect root, you are going to have an irrational answer there. And so these are just asking you to identify, is it rational or irrational? Can you find the root, or are you going to leave it in the sign? All right. And we're not going to do any estimating, and we're not going to do any rounding. We will literally leave it as the square root. So for the first one, A, well, 81 has a perfect root. It's 9. So positive and negative 9 would be the answer, and that would be rational, right? B, negative 1.44. Well, we know that 144 has a perfect root of 12. And this one has 2 decimal places. So as long as your decimal places are even, you're just going to put half of that in your answer. So 12 with 1 decimal place would be the root of this. So 1.2, and they were looking for the negative root. So that's rational. Square root of 5. This does not have a root. You cannot simplify it. There's nothing you can do. They tell you what it has been estimated as, but this is irrational. So if, when we start solving some equations, you get this as an answer, your answer will simply be left square root of 5, because you cannot simplify it any more than that. All right, question. All right, the third one, 4/9. Well, both 4 and 9 have perfect roots. So they were looking for the principal root here, which would be 2/3, and that is rational. 1/3. 1 has a perfect root. It is 1, but 3 does not. And so this one would be irrational, and we would actually leave that as the square root of 1/3. All right. So A through D, all they want you to do is say rational or irrational. You don't actually have to find it. You just want to tell me if it's rational or irrational. All right. So square root of 8, does it have a perfect root? No, that is irrational. 225, even if you don't know this one, it actually does. Square root is 15. That is rational. 75, no, it does not have a perfect root. That is irrational. And 1/4 does. It's going to be 1/2, and that is rational. So what we've been graphing are quadratics, all right, versus linear graphs. They form a parabola. And so if you take a quadratic and you set it equal to something, then you have an equation, all right? The standard form of a quadratic equation is ax squared plus bx plus c equals 0. So ax squared plus bx plus c should look familiar because that's what you graph for homework, all right? And now we're going to set those equal to things, and then we're going to solve for what x can be. So what we can, just like if you were solving 3 plus x equals 5, and we know that x is 2, right? We're actually solving for what we can plug in and make that equation work. All right, and the first way that they show is graphing. We're not actually going to solve by graphing, and the reason we're not is because we are sketching these graphs. And so sketching a parabola is much different than sketching even a line to solve, because there's a lot more room for error. But I do want to show you what they're looking for when they graph. And so if you turn to page 530, we're going to look at these 3. They have x squared minus 4 equals 0, x squared equals 0, and x squared plus 4 equals 0. Now you'll notice your b, so bx is just 0 because b is missing. We have ax squared plus bx plus c. The bx is missing. So when you graph these, it just is a perfect parabola shift up or down. So this first one is a parabola that shifted down. So what they're saying is, what is going to make my y 0? All right, if I plug in an x, what makes the y 0? The y is always 0 on my x-axis. So anytime you're solving these, you are looking for where this parabola crosses the x-axis, because that's where your y is 0, right? If I have a point here or a point here, my y value is 0, and that's what we're looking for, where this equation equals 0. And the two x's that make this 0 are -2 and +2. That makes sense. If I plug in a -2 up here, -2 squared is 4, 4 minus 4 is 0. If I plug in a +2, 2 squared is 4, 4 minus 4 is 0, right? Look at this next one. This one didn't move at all. So the only place that it actually crosses the x-axis is at 0. Well, that also makes sense. If I plug in a 0 here, 0 squared equals 0. That is true. All right? And look at the last one. you'll notice that it does not cross the x-axis at all. That also makes sense because I am taking some number and squaring it, and then I am adding 4. Well, what number can I square to make -4, right? If I square a 0, 0 squared plus 4 is 4. If I square 2, 2 squared plus 4, well, that's 4 plus 4, that's 8. If I square even a -2, -2 squared is 4, right? So there's nowhere that I can plug a number in and get a -4. That's not going to work. And so it makes sense that this never crosses the x-axis and it doesn't have any answers. All right, so that doesn't have any real answers. No real numbers would make that work. All right, and so that's what the graphing shows you, that you're looking for what is going to be able to plug into this formula and make it work. All right, and so we are actually going to solve by taking square roots. Example 2. All right, so when you have something simple like x squared minus 4, you can say, oh, well, obviously 2 or -2 are going to work because that's a nice easy number. But when you have something like this, it's a little more difficult. And so what you're going to do is you're going to actually try to get that x squared completely by itself. All right. So if I have something and I don't have the bx, I just have an x squared and a number, right? Just the x squared is showing up. I want to get the x squared completely by itself. And so I am going to do that by moving out a number that doesn't have the x squared with it and then dividing by the number in front of the x squared, just like I'm solving for x. So I'm going to add 98 to both sides. All right, that's my first step. Once I do that, it will cancel on the left-hand side, and then I will have 2x squared equals 98. And then my next step is to divide by that 2. So I'm going to take both sides and divide by 2. So I get x squared equals 49. Now, when I have an x squared and it equals a number, all I have to do at this point is take the square root. Now, remember I said if a variable is involved, you have to consider the positive and the negative root, all right? So if I take the square root of both sides, I'm going to say that x is going to equal the positive or negative root of 49. And we have done this. We know what this means. The square root of 49 is 7. So my answer here for this is going to be that x equals positive or negative 7. And I can always check it. I can say, well, 7 squared minus 98, and 7 squared minus 98. And if you follow through and figure out what that is, 7 squared is 49, 2 times 49 is 98. That works. -7 squared is also 49. 49 times 2 is 98. And you can see that you have the right answer. All right. So your goal is to move away a number that doesn't have the x squared with it, and then to divide by the number in front of it. So go ahead and solve A, B, and C. All right. So for the first one, you should have added 25 to both sides. You would have gotten t squared equals 25. Taking the square root of both sides, you would have gotten t equals the positive and negative root of 25. So your answer here would be positive or -5. All right. For B, you should have subtracted 12 from both sides. When you do that, you get 3n squared equals 0. And so dividing both sides by 3, n squared equals 0. Remember, the positive and negative root of 0 is just 0 itself. And then for the last one, you would have subtracted 32 from both sides. When you do that, you get 2g squared equals -32. Divide both sides by that 2. G squared equals -16. Remember, when I have the square root of a negative number, it does not exist, so there is no solution there. No solution for that third one.